Do you ever wonder what we would see if we set off on a journey through the universe, all the way to the end of our observable universe? If yes, you've come to the right place. We're about to embark on an extraordinary journey across the cosmos. But first, we need a spaceship, one that can travel at the speed of light with unlimited energy. After all, we don't want the fuel running out near a black hole, do we? And of course, you'll need immortality for this journey, because without it, you might even make it to the next galaxy. So, I am your captain, Mr. Cosmos. Let's board this ship and set sail through the stars. The following journey through the universe is purely fictional and for entertainment purposes. While based on scientific concepts, the events and technology depicted are not currently possible in reality. Our ship can travel at the speed of light, and immortality is granted for this adventure alone. Please remember that our actual understanding of the universe and its vastness is still evolving, and much of what we see today is based on theoretical science. Welcome aboard, passengers. We're about to leave our home, Earth. As we leave, you can see just how beautiful it is. A blue planet, home to trillions of lives. As we pass Earth and escape its gravity, we'll fly by Mars and the asteroid belt, a disk filled with countless asteroids. Continuing forward, we'll pass planets like Jupiter, Saturn, and all the way to Neptune. Beyond the planets lies the Kuiper Belt, a region full of icy objects and distant dwarf planets like Pluto. And beyond that, we reach the Oort cloud, furthest part of our solar system, filled with icy bodies far from the sun's warmth. Now, we're leaving the solar system behind. The sun will slowly fade into the distance, becoming just another star in the sky. As we continue on our path, we leave everything we know far behind. Now that we've left our solar system behind, we find ourselves in the Orion Arm, the same place we call home. But what's next? How do we leave our galaxy? Sure, we could take the shortcut and head straight out, passing through the nearest edge of the galaxy. It's the fastest way to leave, but I have a different plan. We'll go deeper into the heart of the Milky Way, through its center. Yes, it's going to be a long journey. A journey that will take us across the galaxy, all the way to the farthest edge and beyond. As we left our solar system behind, we enter the interstellar medium, the vast space between the stars. Now you can see the nearest star system, Alpha Centauri, just 4.37 light-years away. You might wonder, what makes Alpha Centauri special? Well, it's a triple star system, made up of 3 stars, Alpha Centauri A, Alpha Centauri B, and Proxima Centauri. Of these, Proxima Centauri is the closest, and it even has an exoplanet in its habitable zone. Imagine a planet that might have the right conditions for life. As we leave the Orion Arm, we pass by massive stars like Betelgeuse. It's enormous compared to our sun, around 1,000 times the diameter of the sun. Betelgeuse is possibly nearing the end of its life, and as we travel through, we see various nebula, like the Carina Nebula, Eagle Nebula, and Horsehead Nebula. These vast clouds of gas and dust are the birthplaces of stars. Then we pass through several star clusters like the Pleiades and Hyades, groups of stars that form from the same molecular cloud. Continuing our journey, we witness supernova remnants, stars that explode at the end of their life cycles. These remnants, such as the Crab Nebula, are composed of the debris left behind by these powerful explosions. Now that we've come close to the center of the galaxy, we see something extraordinary. See that glowing object? That's not a star, that's a black hole, and not just any ordinary one, a supermassive black hole, Sagittarius A star. Sagittarius A has an immense mass, about 4 million times that of our sun. Despite its enormous mass, it is concentrated in a very small area, with its event horizon being only about 44 million kilometers, or roughly 0.15 light-years. Surrounding this black hole is an accretion disk made up of gas and dust that spirals in toward it. But we don't want to get too close, because if we get caught in its gravity, we're doomed. It's best we keep our distance from this cosmic giant. As we continue our journey, we move beyond the main disk of the Milky Way, entering the galactic halo. This sparse region is filled with older stars, globular clusters, and dark matter. It's here that many of the Milky Way's ancient stars reside. But we press on, and soon we leave the Milky Way behind. We enter the cold, dark void of intergalactic space, an empty expanse with no stars or galaxies in sight. If you turn around and look back, you'll see the Milky Way shrinking, becoming smaller and smaller in the distance. A vast spiral galaxy, home to trillions of stars, planets, and perhaps even life beyond Earth. As we leave the Milky Way behind, take a moment to look back and admire its faint glow shrinking into the distance. Ahead of us, a hazy glowing shape emerges. The Andromeda Galaxy, the Milky Way's closest spiral neighbor. But Andromeda is not just a distant friend. It's a partner in a cosmic dance that will end in a collision. In about 4.5 billion years, these 2 galaxies will merge to form a spectacular new one. As we journey onward, 2 irregular dwarf galaxies come into view. the Magellanic Clouds. These companions of the Milky Way, the Large Magellanic Cloud and the Small Magellanic Cloud, are shaped by gravitational interactions with their massive neighbor. Within the LMC lies the Tarantula Nebula, one of the most active star-forming regions in the entire local universe. Further along, another massive galaxy appears, M87. It's the largest galaxy in the Virgo supercluster, containing trillions of stars, thousands of globular clusters, and a giant supermassive black hole at its core. This black hole, with a mass 6.5 billion times that of the Sun, captured humanity's attention in 2019 when its shadow was first imaged by the Event Horizon Telescope. As we move beyond the galaxies, the intergalactic medium comes into view, a vast, sparse expanse of matter filling the space between galaxies. Made mostly of ionized hydrogen with traces of helium and other elements, it's incredibly diffuse, less dense than even the best vacuums created on Earth. Finally, we prepare to leave the Virgo supercluster, a colossal collection of galaxies that includes our local group, home to the Milky Way and Andromeda galaxies. At its heart lies the Virgo cluster, a reminder of the staggering scale of the universe and just how small we truly are. As we leave the Virgo supercluster behind, we find ourselves moving into something far greater, the Laniakea supercluster. This immense structure is our galactic city, a sprawling network of over 100,000 galaxies, all drawn toward a gravitational focal point called the Great Attractor. The Great Attractor, though shrouded by the dense plane of the Milky Way, exerts an enormous gravitational pull, guiding the motion of galaxies across millions of light years. Continuing outward, the scale becomes truly staggering. The Laniakea supercluster is not alone. It is merely one part of a far larger structure, the cosmic web. This is the grand design of the universe, where galaxies and superclusters form interconnected filaments stretching across billions of light years. Between these filaments lie vast voids, immense regions of near-empty space where only a few lone galaxies exist. Looking back, the Laniakea supercluster fades into a thread of light, one among countless others. The cosmic web itself forms a tapestry, a skeleton of the universe shaped by gravity, dark matter, and the remnants of the Big Bang. Every filament, every cluster tells a story of creation, connection, and cosmic scale. When we leave the cosmic web, the large-scale structure of the universe, composed of galaxies, clusters, and superclusters, we approach the edge of the observable universe. This is where the cosmic microwave background, CMB radiation, resides. The CMB is the faint afterglow of the Big Bang, marking the limit of what we can observe due to the finite speed of light and the age of the universe. It represents the furthest point from which light has had time to reach us, a snapshot of the universe when it was just 380,000 years old. Crossing this boundary means stepping beyond the limits of our observable cosmos. Beyond the observable universe, we enter a realm of speculation and wonder. Theories like the multiverse suggest the existence of countless other universes, each potentially governed by different physical laws and constants. Could there be other Big Bangs, each giving rise to a distinct universe? Could these universes be vastly different from ours? Or might they share familiar traits? As we venture beyond the known, we confront the infinite unknown, a frontier where our understanding fades and the possibilities become as vast as the cosmos itself. This is the edge of everything we know, and perhaps the beginning of something far greater. So we've traveled far and seen so much, yet we've only scratched the surface of what's out there. The universe is so vast and our knowledge so limited. But one thing is clear, the cosmos holds wonders beyond imagination. The journey doesn't end here, it continues, and perhaps someday we'll discover even more about the universe, our place within it, and what lies beyond. Until next time, fellow traveler, I'm your captain, Mr. Cosmos. See you in the next one.